All right, hello and welcome to the basics of two-dimensional forces. In this video, we're just going to talk about a few concepts that you need to understand before you really get into two-dimensional forces. The first question is, what is net force and why does it matter? Well, it matters because in Newton's second law, acceleration is net force over mass. So finding the net force is very, very important. Now, what is net force? Net force is just the sum of all the forces in all the dimensions. So if you have an object like an Angry Bird that has a force A to the right and a force B to the left, then the net force is just FA minus FB. The net force is equal to FA minus FB. So let's say FA was 10 newtons and FB was 7 newtons to the left. Then your net force would be 10 newtons minus 7 newtons. Therefore, it's 3 newtons to the right. Your net force diagram would look like this. Your net force is equal to 3 newtons to the right. So that's what net force is. The second concept you need to understand is that a force can be in two dimensions at the same time. And what I mean by that is we have an x dimension, which is parallel with the ground, and then a y dimension, which is vertical. So we have x, we have y. All right, you can have a force that's straight to the right. You can have a force that's straight up, and that's cool, but it's kind of boring. What I'm talking about is we can have a force that's at an angle. It's neither straight up or to the right. So let's call this FC for F. Cool. It's a cool force. All right. The force is at an angle. Let's say the angle is theta. All right. Imagine if the sun was shining way up here. It's going to cast a shadow down along the horizon that's going to be this long. That shadow is what we're going to call FC, that's in the x direction. Now imagine the sun shining over here. It's going to shine a shadow onto the y-axis that looks like this. We're going to call that FCY in the y direction. Now we have broken apart FC into FCX and FCY, the components. And briefly, let's say FC equaled 30 newtons and theta equaled 40 degrees. Then to find the force of C along the x-axis, all you do is 30 newtons times the cosine of 40 degrees. So you just, in your calculator, do 30 cosine 40, enter, and you get out 22.9. Make sure your calculator's in degrees. Right? And for y, just do the same thing, but use sine to find the opposite component of that triangle. And you also have to understand that this component right here is also FCY. And this component right here is also FCX. It's just drawn at a different spot. All right, so that's components of a force vector and what a net force is. Stay tuned to the other videos to learn some more.